Hey students, Mr. Halpern here. So this is going to be the first in a series of several videos that really go through the basics of oxidation and reduction, and then we go into oxidation numbers, and then finally balancing redox reactions and identifying redox agents and oxidizing agents, and finally finishing up with E0 cell potential. So we're going to start off with the basics. Some reactions happen because there's something that's transferred from one element or substance to another, and what happens is it makes those substances charged in a way that attracts them to each other. And that substance that passes from one substance to another is an electron. So electrons are being passed during what we call oxidation reduction reactions or redox reactions. Redox is just a word that crunches the words reduction and oxidation together. Really, at its core, it's just an electron that's passing, say, from substance A to substance B, just like that. And we have specific names for substance A and substance B because they are doing different things, right? In the case of A, we see that there's a loss of electrons. It's lost one electron in this case. We call this oxidation. Oxidation. And then conversely, B, the substance that received or gained the electrons, is being reduced. That's reduction. So oxidation is losing electrons, reduction is gaining electrons. And when we're doing these types of reactions, you can't have one without the other. You can't lose electrons and then have them just sort of disappear without something else accepting those. And conversely, you can't gain electrons without something giving those electrons to you. And this changes the nature of the elements that you're dealing with here. So one thing we note is that when you are adding electrons, when you do that, you are going down in charge. So if I'm taking on something that is negative, more and more negative electrons, my substance, me, I'm going to be more negatively charged. And so the more I go down, down, down and add more electrons, I'm going to be more negatively charged. It could be just adding one electron, so +3 to +2, or adding 3 electrons and going from +1 down to -2. Okay, so that's important to note. And conversely, if you're losing electrons, your charges will be going up. So you might go from 0 to +1 or +1 to +3, depending on how many electrons you lose. Now, you might be sort of, curious about oxidation reduction. How am I going to remember this? Because it's really important to remember oxidation means losing electrons, and reduction is the gaining of electrons. And so we have a mnemonic. And the mnemonic is oil rig. Just like the technology that we use to pull oil from the ocean floor. So oil rig, this means oxidation is losing, right? In this case, electrons. And then reduction is gaining. In this case, gaining electrons. So let's look at an example of this in a real reaction. One of the most foundational reactions that we can talk about is the formation of salt, NaCl, or A salt. And one thing to note, Na and Cl, they can be completely without a charge. We talk a lot about them being charged, but before they are charged, they're actually neutral. And so these elements here are considered to be neutral by themselves. Now, when they start off, they're going to be neutral. So the first step is to realize that there is no charge on either one. But what's going to happen is sodium has one extra electron on its outer electron shell or energy level. It wants to give it to something else that needs it. Chlorine is missing one to have a complete electron shell on the outside. And so what happens is there's a transfer of electrons. And as a result of that, sodium becomes positive and chlorine becomes negative. Hey, and guess what? This is the foundation for why ionic compounds form. When there's a transfer of electrons, suddenly one thing, in this case sodium, becomes positive, and the other thing, chlorine, becomes negative. And so this makes a molecule, NaCl, where the opposite charges attract each other. So this is really just the process of making an ionic compound. And we can describe it in certain ways. So when sodium is losing an electron, right, it's being oxidized. And the way that we write this as a formula is saying that sodium, Na, is now losing an electron. It's going to become positive. And the way we write that as coming out is not subtracting an electron, but in fact, adding electron to the right-hand side. We can't subtract anything in chemical formulas. So the way that we solve that problem is by taking that subtraction and moving it over to the right-hand side, and we have an electron on the right-hand side. So just remember that when you're being oxidized, you're losing an electron. The way we show that in a reaction is on the right-hand side. This is called a half reaction. It's called a half reaction because it's only one half of the redox reaction. This is just oxidation, remember. Now, we can't have only half of the reaction. We have to have both. Remember, we can't have a redox reaction without both oxidation and reduction. And so chlorine is the substance that's accepting or gaining the electron from sodium. So it is being reduced. So how do we write that? Well, chlorine, Cl, plus E negative, which is representing the electron that it's gaining, becomes or makes Cl minus because it added that electron. And again, this is a half reaction. These are important, these half reactions. And they're going to become important when we're balancing these redox reactions and we find certain things like reduction potentials for the cell. When we put this back together, right, we have a redox reaction. This is a redox here. This is the full reaction, reduction and oxidation, right? And so the way that we can draw this is by writing it out and then identifying again, and I'm kind of hammering this in, and I know, but what is being oxidized and what is being reduced. So we'll start off with sodium. Again, we see that sodium, which is a 0 charge, is going to a +1. So this is going to be oxidized. And conversely, chlorine is going from a 0 charge to a -1. And a -1 is making more negative. Why? Because it's gaining electrons, and so that is being reduced. It's a little bit confusing right in the beginning because you think that Reduction shouldn't mean that you're gaining something, right? We typically think of reduction, reducing like you're losing something, but the opposite is true in this case. The reduction is happening because you're gaining electrons, and the charge is being reduced. And the last thing I'll talk about is agents, and I think I'm going to talk about that in another video.